Ayo, ayo, ayo. This is Mr. G coming at you with the video for writing inequalities. So, first thing I want to say about writing inequalities, you guys, is that if you have not already watched the video for writing two-step equations, I would make sure that you watch that because they're very similar. The only difference is that instead of an equal sign, we're going to have an inequality symbol. But for the most part, they're the exact same thing. So if you haven't watched that video, you need to watch that first because that is going to go a little bit more into details about strategies. This one, I'm expecting you to know that stuff. And then we'll just talk about how you know if it's an inequality or not, and then how we know what symbol to use. Okay, so here's your key idea right here. Writing inequalities is very similar to writing equations, except we have an inequality symbol rather than an equal sign. Okay, pretty basic stuff there. Just like if you guys have noticed with solving one-step inequalities, two-step inequalities are going to be very similar. And yeah, so here I have a quick number sentence, very simple. And this is not necessarily a word problem, but it's a number sentence that we're going to look at, just kind of talking about keywords with inequalities. So 1/3 of a number decreased by 36 is at most 22. Find the number. So first thing, I'm going to kind of replace all these with numbers just so I know what I got here. I got 1/3 of a number. So 1/3 of a number. So do I know what that number is? No, that's my unknown. So 1/3 of a number would be the same thing as 1/3 times x. So what I did is I just took the 1/3 of a number. I wrote what actually is happening there, which is 1/3 times x. I'm taking 1/3 of a number. Okay. Decrease by 36. Decrease means subtraction. 36, I'm just going to write the number 36. I'm kind of writing out what I have here. Is at most 22. Okay, so I'm going to rewrite this down here just so we can kind of get a better idea of what's happening. Is at most 22. So it's not saying that it is equal to 22. That is the difference between an equation and an inequality. An equation would say, oh, that's equal to 22, is 22. But it's saying is at most 22. So we got to ask ourselves, what does at most mean? Does that mean it's going to be either greater than 22? That means that this number over here is going to be bigger than 22? Does that mean that this value over here is going to be smaller than 22? Or does that mean that it also could be equal to 22? So we got to ask ourselves, is it going to be smaller than or equal to, or less than or equal to, greater than or equal to? Okay. If we think about the word at most means it's not going to be any more than 22. So because of that, I know that 22 is going to be the largest number. But because it says at most, if I said or equal to underneath, I think that would work as well. Because at most means, yeah, you could possibly be 22, but you're not going to be more than 22. So that means you're less than or equal to. So what you're doing is you're taking the keyword of at most. You might see at least as another keyword you might see. Okay, you might actually see greater than. You might actually see less than. It's just taking those words and translating it into math. And you got to figure out what it means. You actually might have to talk to yourself about, okay, at most 22, at most 22. Well, if I said I can have at most $22. I always translate it to money. If I can have at most $22, that means I can't have more than $22. The most I can have is 22. Okay, but I also could have 22 because it says at most. So that's why I have the or equal to. So I can have at most $22, or the number can be at most 22. So that's why this is the largest possible value. That's why everything on the left has to either be less than or equal to. And then we're done. We don't need to solve it today. Okay, I'm just going to stop there. If you wanted to solve it, you would solve it the same way as a two-step equation. But let's move on to the next one. Okay, so I'm going to underline some key terms here. Jack wants to run, at least is going to matter. Okay, 275 miles before the baseball season begins. Okay, so this is it looks like I already got my total amount of miles he wants to run, and everything else is going to give me what he's going to do, and I already got the key term for my inequality, which is at least. He has already run 25 miles. He plans to run 2.5 miles each day. At this rate, what is the fewest number of days he will need to reach his goal? So we don't know how many days. That's what it's asking us. What is the fewest number of days? We don't know that. So there's my variable. That's why I put an X right above it. Okay, 2.5 miles each day. So right away, I know I'm going to have a 2.5 times x. Because if I'm running 2.5 miles each day, I can take 2.5 miles, multiply it by how many days I run. Okay. I also know I already ran 25 miles. That's already done. So I know that 2.5 miles each day plus that 25 miles is going to get him to his goal of 275 miles. Okay. Then we would need to solve to figure out how many days that you need to run. But now we got to figure out which inequality is simple to use. So Jack wants to run at least 275 miles. So we got to think of what does that term at least mean? So if I want to have at least I always bring it back to money. If I need at least $275 to buy an Xbox, then if I need at least $275, I can have $275 or more. That means $275 will cover the cost of the Xbox, but of course I can have a little bit more money than that as well. So that's the same thing here. That means if I want to run at least 275 miles, 275 miles is the minimum. I could also run more than that. So we know it's or equal to because that at least means I could run exactly 275 miles and that would be fine. So that's the or equal to symbol. I also know I can run at least 275 miles, meaning that the 275 miles is the smallest amount that I would run. So that's the or equal to, but I could also run more. So this is the amount that I'm going to run. And if this is the amount that I am going to run, then this can be equal to 275 miles or it could be more because it says at least 275 miles. Okay? And again, think about it back to money. All right, I only got one more for you guys. So Ella has $40 to spend. So she's got $40 to spend at the state carnival. Admission is $6. How many times you pay an admission fee? Just think about that to yourself. Okay, how many times you pay an admission fee when you have to get somewhere? And each ride costs $3. Write inequality to find the greatest number of rides she can go on. So admission, this is your one-time thing. You pay your admission up front once. Then you have to continue paying for each ride. Well, each ride is $3. I don't know how many rides we go on. That's what we're trying to find. So there's my 3 times however many rides we go on. Okay, and that's what we're trying to find, greatest number of rides. And we know that she has a total of $40. So we got to figure out how many rides can Ella go on. Well, let's think of it like this. If you only have $40, are you able to spend more than the amount of money that you have? The answer is no. I cannot. If $40 is the maximum amount of money I have, that means I cannot spend more on this side. Okay, so $40 is my total amount of money. I cannot spend more, and this is how much money that Ella is spending. Ella is going to spend $6 to get in, plus $3 for every ride. So therefore, she cannot spend more than $40. She has to spend less than $40. But she's allowed to spend exactly $40. That's how much money she has to spend. So I'm going to put the or equal to symbol there. So if I look, $6 for admission to get in, plus $3 for every ride, has to be less than or equal to the $40 that she has because she cannot spend more money than what she has in her pocket. Okay? All right. Well, that's all I got for you guys. Oh, math joke. I almost forgot again, but luckily I didn't. Why is it impossible for a nose to be 12 inches long? So why would it be impossible for your nose to be 12 inches long? Because, ladies and gentlemen, then it would be a foot. Woo! That was a good one. I'm proud of that one. I like that one. All right, hey, hope you guys liked the video. And if you have any questions, please let me know. G out.